All right, so we are leading to the point where we're going to need to identify the vertex of graphs where it's not just a shift up or down based on C, but we're going to use a formula, negative b over 2a in a little bit. But the first thing we need to be able to do is identify our a, b, and c in a quadratic equation when it's in the form of ax squared plus bx plus c. So the only two steps, and this is not bad once you kind of see it and get the hang of it, is we want to make sure the quadratic is a standard form first. That's when the highest exponent's listed first, and then you have the exponent, and then you have c, which will be our whole number without any type of variable with it. And then you list a, b, and c, and you're including their values. So if it's negative, make sure you're putting it as negative. The biggest confusion, I think, when we're getting started with this is that recognizing that your a and your b especially are different from your x and your x squared. It's just the coefficient that goes with that. So when I'm listing my b in these problems that we're about to do, do not list the x with it. Okay, so if we're looking at these first example problems, these are all problems that are in standard form. We are listing our a, b, and c for each one. So in this one, for example, our a is 2, our b is 4, and our c is 5. So again, pretty straightforward when it's in standard form. In this example, we have negative 3 as our a, we have positive 5 as our b, and our c, we want to list that negative with it, so we have a negative 3. All right, in these two examples, I wanted to point out, because you notice that there's not 3 terms, so you still have a value for a, b, and c in this type of problem. So if I'm looking at this, my a goes with my x squared, my b goes with the x, and the c is just the whole number. Well, in this one, you can see we have an x squared term and an x term, but we don't have a c. So in this case, our a is going to be 10, our b is going to be negative 4, and since you don't see a c, if you don't see it there, we list that as a value of 0. So in this example here, all right, if you're noticing this, we have our a term because there's an x squared, but we don't have a b because there's not a standalone x like we do here or we do here. But we do have a whole number which is represented by our c. So in this case, our a is going to be positive 4. Our b, since there's no x term, is going to be equal to 0. And then our c would be equal to 5. All right. I'm going to write this here. I probably should have put this as an example. If I have, for example, an x squared minus x plus 2, you list a, b, and c. Just remember that if you do not see the number, but you see that variable there, then we are assuming there's a 1 there, right? So in this case, our a would be 1, our b would be negative 1, and our c would be positive 2. And that'll come up often too. You'll see just the x squared. Just know that your a is 1. That's probably the majority when we get into graphing and factoring and solving using the zero product property, which will make sense later. You'll see that a lot of times your a is 1. You will see this from time to time, not often, but to be able to list your a, b, and c, I mean, you can maybe look at it without rewriting it because your a goes with the x squared, your b goes with the x, and your c is your whole number. But what I like to do is look at these as our terms, and we reorganize our terms in standard form. If it's not in standard form, it's good practice, and you'll see when we get to these, we'll be listing them in standard form. So in this problem, I would rewrite, I put the x squared first, so this would be negative 6x squared. And then our 4x, and I'm going to put the positive 4x there because we're representing the value when we are separating terms. And then we have our positive 3 at the end. Once we do that, now you can see your a, b, and c. My a is negative 6, my b is 4, and my c is positive 3. All right, same thing over here. And as we're going, if you want to pause these and kind of test yourself, go ahead. But my first term is going to be the positive 2x squared when I rewrite this. My second term is that negative 4x. And my third term, or my c, would be a positive 5, so I'm going to indicate that with that plus there to separate those terms. Now I can see my a, b, and c. My a is 2, my b is -4, and my c is +5. All right, so the last type of example is when you have two binomials and we're multiplying them, because these are going to multiply to equal a quadratic or trinomial where that lead coefficient has our first term, our lead term, is going to have an x squared. So in these examples, we can still list a, b, and c. We just have to multiply or FOIL to get there. So I'm going to do the box method here, because I know a lot of you guys prefer this method. So I'm going to list my 3x and my 4. It doesn't matter which side. So 3x, my +4. Then I have my 2x and my -7, and I'm going to multiply. So this is going to be 2 times 3, which is 6. And then x times x is x squared. 2 times 4 would be 8. And I'm going to include that x there. 3 and -7 gives me -21x. And then I have a -7 and a 4, which would give me -28. And now I'm going to go ahead and add these together and combine the like terms that we have. So when I list this, I have 6x squared. Then I have 8 plus a -21. If you're not sure, of course, use your calculator. So 8 plus a -21. Oops. It's tougher on this. On your calculators, it makes more sense. I'm just going to do 8 minus 21, because that's the same thing, and that gives us -13. So -13x, and I have my -28. And once I have this, now I can list my a, b, and c. My a is 6, my b is -13, and my c is -28. All right, just again, another practice problem here. We're multiplying. I'm going to set up my box and multiply this. So I can have x here and a 10, x and a -10. So x times x is my x squared. X times 10 is 10x. -10 times x is -10x. And -10 times +10 would be -100. So now I go ahead and I combine these terms. So I have x squared. These two are like terms. -10 plus 10, or 10 plus a -10 equals 0. So I'm just going to leave that term out completely. And then I have a -100. So now, just like the example up here, where we have an a and a c, but we don't have a b, I can then put my a, b, and c values here. So I have an x squared. The value of my a is 1, because if it's not there, remember, it's a 1. There is no b term, so I can put 0 for that. And then c would be -100.